All right, this is AP Prep number 7, at least in the year that I'm recording this, and I want to take a look at problem number 1, which is relatively basic but may not look very basic to you. Anyway, they ask you to write the first four non-zero terms of e to the negative x squared and the general term about x equals 0. So what they're really telling you here is that you should be able to use the e expansion here. So that's what the e1 looks like. And again, you should know what these look like. So e to the negative x squared, your input is being replaced with the negative x squared. So you're replacing your input, your x, with the negative x squared. So that would be 1 plus negative x squared plus negative x squared to the second power over 2 factorial plus negative x squared to the third power over 3 factorial. And we have 4 non-zero terms there, so we can continue. Now, sometimes you might want to simplify these. For example, this is going to be 1 minus x squared. That'll be plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial. You know, sometimes you're going to be able to see things like it's an alternating series. Sometimes it's going to be easier to look at this to try to write the general term. Sometimes you might get some simplification or something like that, and it's easier to look at that. Unfortunately, I can't really give you a strong answer on which one. In general, though, all I did was take the x to the n over n factorial, and I put a negative x squared in place of the x. So I think it's just as easy to stick it into the general term. It's negative x squared, and then you're taking it to the n power over n factorial. And so you could write it like that. Now you could rewrite that as negative 1 to the n times x squared to the n. So I'm going to write it as negative 1 to the n times, actually x to the 2n is what it ends up being over n factorial. Okay, so there's our first part of this. Okay, and then part B, hopefully I have the right answer there. I think that looks good. We'll check the answers in a minute. I'm going to go into part B. Part B here, they want me to find the limit as x approaches 0 of 1 minus x squared minus f of x over x to the 4th. And you know, on the surface you look at that and you think, oh my gosh, what is going on here? But if you just kind of suck it up and fill in values and look at what's going on, a lot of times these are not terrible, okay? So I'm going to take the expression. I'm going to start out with a 1. I've got a 1 and then minus an x squared. And then I'm subtracting this entire series. Okay, and the series is 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial and so on. And then all of that's being divided by x to the 4th, okay? But take a look what happens here. I've got a 1, and I'm subtracting a 1, okay? So the 1s are going to cancel. And then, again, be real careful with your signs. I've got a negative x squared here. I'm subtracting a negative x squared. So that's going to be a positive x squared that'll cancel the negative x squared, okay? And so what I really have here is x to the 4th over 2 factorial minus x to the 6th over 3 factorial, and then plus x to the 8th over 4 factorial, and so on. All of that's being divided by x to the 4th, and I'm trying to find the limit as x approaches 0 of this whole thing. Well, take a look here. Each of these is divisible by x to the 4th, so I can knock out a bunch of x to the 4ths. This is going to end up being the limit as x approaches 0 of 1 over 2 factorial. When I divide this by x to the 4th, it's going to knock out the x to the 4th. Then it'll be minus x squared over 3 factorial, and then the x to the 4th will knock out 4 of those x's, and that'll be plus x to the 4th over 4 factorial, and so on. And that pattern is going to continue to infinity. Well, what's going to happen as x goes to 0? This term goes away, that term goes away. All of the future terms are going to go to 0. Oh, I missed a sign here earlier. Where is it here? Oh, yeah, we're subtracting all of these. So that should be negative, that should become positive, and so on. So I'm sorry, my signs are all switched on these. Okay, and so this can be negative, this is going to be positive, and that because I was subtracting the entire function. It's going to flip all the signs and everything. Anyway, though, all of those terms go to 0, and we get negative 1 over 2 factorial, which is just negative 1/2. Okay, so that's not terrible.